Okay, let's have a look at this circuit. We have a 12 volt battery. Again, the power source could be anything, but we're using a battery here. We go along to an ammeter, and the ammeter is in series. Remember, that's how the ammeters work. And then we go along, we've got two parallel lines. Alright, two parallel lines back round to the battery. This ammeter here will give you the reading of the total ampage in the complete circuit. Okay, and this ammeter here will tell us how much current is going down this parallel line, and this ammeter here will tell us how much current is going down this parallel line. What actually influences these ammeters is the components here and their value. Okay, so if there's more resistance there, you'll probably find the current will be less, because the current comes along and goes, oh, here's an easier route, so more goes down that way, and some take the harder route where there's more resistance. Well, that's the theory. So let's see if we can actually work this out then. And it's Friday, so bear with me because there might be a few wee mistakes. So let's first of all, let's find the total current in this circuit here. In order to do that, we need to find the total resistance of this circuit. And before we can do that, we'll need to do two equations actually. We'll need to add these resistors up, because these two resistors and these three resistors here are both in series. So as I keep saying, like a TV series, it comes on one after each other. We just simply add them up to make one big resistor. So we'll have 500 and 500 ohms. That gives us one big resistor here of a kilo ohm. We then have a 1 kilo ohm, a 1 kilo ohm, and a 1 kilo ohm resistor. So it's 3 kilo ohms. So you go 1, 2, 3. So this becomes one big resistor of 3 kilo ohms. So that's the total resistance on each line. But we know we've got this formula that we need to use to calculate total resistance in parallel. So it's 1 over RT, so 1 divided by resistance total is equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3, etc, etc. So we've just made R1, which is 1 kilo ohm. Remember, we've just made one big resistor here, which is 1 kW. And we've just made R2, which is one big resistor here of 3 kW. 3 kilo ohm. So let's put them in the calculator. So bracket 1 divided by 1000, that's a new R1, plus bracket again 1 divided by 3000, so I made a back side of there, equals 0.0011333333. So as you can imagine, we're going to be rounding this up, alright? So 0.00133. Okay, so it'll be 1 divided by 0.00133, and that equals 751.87. Let's make it 752 for talking sake. Okay, so the total resistance of this circuit will be 752 ohms. Okay, so if you remember our wee triangle, we have V equals IR. We want to find I, so we cover I, so we V divided by R, so in this case we have 12, so it'll be 12 volts divided by 752 ohms. Let's see what that works out at. 12 divided by 752 equals 0.015957444 etc etc amps. And here you can see 16 milliamps. Okay, so obviously it's rounded up to 16, and 1015 and then a 9, so you round that up to 16. So of course 16 milliamps would be 0.016 amps. And we always remember Ohm's law when we do the calculations: to keep yourself right, put it back into amps, put it back into ohms, and put it into volts. So we know that this here is 16 milliamps in the total ampage. Okay, so let's see if we can work out what the ampage is going to this part of the circuit. Well, calculator back out. So it's V equals IR. And we want to find I, so it's V divided by R. So it'll be 12 divided by 1000. Because remember, 500 and 500, that gave us one big resistor of 1000. Equals 0.012, so 12 milliamps. Okay, 12 milliamps. Let's play the circuit. Boom, 12 milliamps. Alright. And let's do the next one. V equals IR. V equals IR, so it's going to be 12 divided by, and what we got here, 1, 2, 3 divided by 3000 equals 0.004, so 4 milliamps. Okay, let's play the circuit. 4 milliamps. So you can see 12 plus 4 gives us 16. Okay, so we know we've done a calculation right here because we've worked out 12. We know we've done a calculation right here because we worked out 4. If you add 12 and 4 together, you get 16, and that's the total ampage of the actual circuit. So that's how we work it out, folks. We need to remember, because they're in parallel, we just create one big resistor. So you add them up, and just imagine you have one big resistor at that value. You add that up, you have one big resistor at that value, and that's the figures that we use for calculating current. Hope that helps you.